Hello and welcome to another Robolink tutorial. So today we're gonna be programming the turret bot. So before we start this video, I recommend that if you haven't watched the introduction tutorials about how to use the components, that you go back and watch them, because we will be using things such as motors and sensors, and it would be better if you know how to use them. Alright. So the turret bot is basically a robot that you can, by using the sensors on the board, you can control this little turret, and if by pressing either the left sensor or the right sensor, if you touch the middle sensor, it shoots a rubber band, one rubber band at a time. So the first thing we're gonna put in our code is the include smart inventor.h library. This is gonna let us use each of our um, components like motors and sounds. We're also gonna make three global variables. These global variables is gonna be the locations for our top three sensors, so middle, left, and right. Um, so again, we're gonna use this to declare when we call the sensors. There's a few other global variables. The next one we're gonna be using is speed. So by now, if you watch a few of our tutorials, you'll notice that we try to make a variable called speed for each robot if we're using a motor. The reason for this is because if we end up wanting to change the speed eventually, we can just change this number instead of having to go back and change each motor individually. If you look at the screen, I also put the sensor offset. This is something that we use a lot as well. This has to do with the sensors because we're using a calibration. We want to make sure that our sensors don't accidentally flag, so we use this offset to check against it to change what the base value is by a little. We're also going to introduce three variables. Again, these ones are going to be your default values for your three sensors. So whenever there's nothing blocking the sensors, these are going to hold that value. And then that way when we put our finger on top of the sensor, we can see a clear difference on both of them. The next thing we're going to do is we're going to work on our void setup. So void setup, we're going to do a few things. By now, again, if you watch a few of our videos, it should be pretty standard. We're going to initialize our pins. So it usually is just easier to initialize them all. So we're going to just declare them all as outputs. And then we're going to make sure that they're low so that we don't accidentally start them with them on. And so this is going to make sure that they're off. We're also in here, we're going to do two more things. We're going to make a call to our smart inventor.dc motor use. So this is basically telling the board that we're going to be using motors and setting all that up. And we're also going to calibrate our sensors. So the way we calibrate our sensors is, as I said before, we're going to call this function. So we're going to declare our defaults, and we're going to call smartInventor.sensor calibration. We're going to tell it the pin that it's going to be calling, and we're going to subtract the offset. The reason why we're doing this is when there's nothing in front of the sensor, it's going to read a value. Now, if you hardcode a value, let's say you put 800, 700, or whatever, you're going to be limited to that, and if your robot is not fine-tuned to that with the onboard potentiometer, you're going to have issues and your robot's not going to work. So what this does, it takes a sample of the sensors when they're being turned on, and it checks what it's most commonly seen. So the lowest value it sees, and then it stores that. And then we take off the offset so that we can fine tune how close your finger has to be to the sensor before it triggers.